So when we do this, we're gonna assume some really basic things, okay? Now the building, the attachment to the building is not there, right? We're dealing just with facade. So I want everybody individually to make their own sort of skeleton, right? Which is, column and slab. All right. We're using that more as a visual thing versus it's not a proto. We're not prototyping slab and column. Although eventually these facades can become structural and become columns, right? And they can also become like mechanical systems, right? Carbon fiber, you can heat it up very easily with low voltage and get it up to like 220 Celsius. It's unbelievable. They do this for, especially shipbuilding, to help the resin cure. If they're using carbon fiber forms, they'll heat up the forms to cure the resins. So you can, maybe not 220 Celsius, but you can get it really hot. All right, so let's look at making a new document. And all I'm going to do is start really basic. So I know there's, I want you guys, let's stumble through this. I won't do it for you. You tell me what should I do first? Rectangle, right? So. And there's different types of rectangles. Let's create a rectangle on a plane. Again, I have no idea what this component does. I can right click on it and go to help. At least I can understand what the inputs and the outputs are. All right? So it's asking me for X dimension of rectangle in X direction, dimension of rectangle in Y direction. Okay. So we can grab a number slider. And we'll set this, we're in feet, so we can deal with feet, so let's set this to 2. There's our column profile, right? A little hard to see there, but that's, oh, where is it? There it is. We can't see it. It's in the grid. Okay. Sorry. Once we extrude it, we'll be able to. All right, so it should be in the grid here because the reference grid is showing. We can't see it, but it's there. Okay, so what can I do next? Before. Extrude, right? So all I'm doing is double clicking and starting to type the same commands I use in Rhino. That's it. You don't need to know the components. They're slightly different sometimes. Or you might have more options, but as long as you know what you want to do in Rhino, you can know what you're going to extrude. Now, it says here, what is this? We want the base. So, sometimes, why wouldn't you just say like curve or geometry? They use base, profile, curve, or surface. So we know it's the rectangle. Then they want to know direction. And the direction is based on vector. Okay? So that's based on direction and magnitude. Okay? So which way, so this is where it could get complicated. Which way do we want to move this? And what direction is that? Z. So what I need to do is use, so this is where you can say, I don't know what component that is, right? So let's just, let's just type in Z. By just typing in Z, I get this little thing that says unit Z. And it's an arrow. Looks like it's a vector. So I'm going to go, okay, maybe it's this. So what is this? If I right click, help. Okay, so this is a unit vector parallel to the world Z. All right, that sounds good. F is a number. Unit manipulation. Okay. And then the output is going to be a vector, which would I want. So by default, I can put a number. Right now, there's 1 in there. What do you guys think 1 represents? One time? Well, it's definitely positive. It's not negative. So we'll use the word magnitude. And for us, we measure magnitude in feet. So it's representing 1 foot. So it's saying, give me a vector moving in that direction with a magnitude of 1 foot. Okay? So if I plug this in, I'm going to get a little extrusion. But it's just 1 foot tall. So we need a number slider. So we want to go 14 feet tall. So I'm going to increase this because maybe one day we want to go 20 feet tall. Well, I'm going to set this to 14. And plug that in. And then I'll remove this to 14. Again, we'll just type it in. Okay, so that's our column at 14. I'm going to reduce this to 1 foot. Alright, so we're at the right size. Okay? So far, so good? Now what do I want to do? What's it? Array? Yeah. So it's array. So let's try. Double click array. So there's a box array, there's a rectangular array. We did a rectangular array. So I'll go for that. Doesn't know what it does yet. Right click. Base geometry. Okay, I want that to be my column. Rectangular array cell. Okay, we'll see what that is. Number of elements. And the X and the Y. Okay, so this is probably the cell size. How big is it? And then how many do I want? In the X and in the Y. That's what that's saying there. So number of elements in the X, number in the Y, and then how big is the cell? Okay, so we'll put that in there. So there's something defaulted in here. You're like, whoa, that's not what I want. But there is 6 here, 3 here, and an offset of 10, and it's looked by 5. Okay, so this thing is offsetting 10 by 5. So we can go here. If we right click here, we can. It's looking for a rectangle. That's interesting, right? So it's saying plug in a rectangle and we'll get the X and Y out of it. So it's looking for the cell, rectangular array cell. All right, we had a rectangle here. We don't want to use the same rectangle. So can I plug in a rectangle there? Oh yeah, that worked. Now I can say I want that cell to be based on my span, so let's go 40 feet max. And let's make it 20 feet. So now this is my cell size based off of a rectangle. Okay. And now I want to tell how many I want in the X and the Y. So I can grab another number slider. I'll just copy and paste in it. I'm going to change this to integer because we can't have a half of a array. Sorry. I'm going to set this to just 2 for right now. Well, let's set the max, let's say 10. And let's say we always want it square, so we can always... So there you go. So we have our size now we can adjust. We have how many columns we have, how tall it is. All right. Yes. Cap it. Yeah. You got to cap it. Yeah. So there's a cap command. So this is a good question. If we look at our extrude, it's hollow in the middle. So we would have to actually apply a cap, holes, cap it, and then plug that in for G. So cap means put a cap on it. If we go in Rhino and we have a rectangle and we say extrude that, you know, we have the option of solid. All right, so it doesn't translate one-to-one, but you might visually see like, hey, this thing's not being capped. So, yeah, so, you know, we contend with those things, especially when we start making our floor slab next. Okay. What do you think? Is this, how do you guys feel about this so far? A little bit better because it's column, right? It's not crazy geometry. So let's do a slab now. All right. So do I have a rectangle? Yeah, I'm using a rectangle for the cell, right? So I want my slab to be potentially where my rectangle is. But if I increase my column size, right? If I increase my count, I want my slab to be all the way out here. So we can use other techniques to do this. One is a bounding box. And what a bounding box does, it creates per object a bounding box, but if I go ahead and I should be able to be able to do that. Hold on. So what we need to do, there's two settings for the bounding box. There's the per object makes a bounding box. We want actually a union box. Okay? So that creates a box around our entire shape. Okay? Now what do we want this? If I can then get this surface, okay? Because I know that's where my slab wants to be. So I can do a B rep, which is the deconstruct B rep. Plug that in, and then I can get a face, right? So if I do a list item. So a list item extracts one face. I'm going to turn these off. Right now that's not the correct face. So I'm going to go ahead and grab a number slider. Turn this to an integer. So it's number 5. Okay. So now I have this top face isolated. Okay. And again, there's probably like 20 ways to do this, if not 200 ways. Like using different components. So what would be another way of doing this? Is, well, we know what, we can use math, right? We know we have 20, whatever this is, and then we have our count, right? So if we do multiplication, and we say cells, and now we have to be careful because we really have 2, right? This is 3 columns, 2 cells, so we need to do a subtraction. And we'll set that to 1. So we always need to reduce this by a 1. So this gives us the size of that cell now. So if this is 25, right, this is going to be 50. And then we can make a rectangle. That's, you can see it down there. So that rectangle is as big as our cell. Let's just do a surface. Do you guys see that? So that's another way of doing it. So that way, if I increase now, if I change the size, the rectangle is going to change. If I increase it. Okay? Many ways to do these things. And this is where it becomes difficult, but I think when you guys are modeling in Rhino, there's many ways of doing things, right? So the best way to start this, if you're not sure how to maybe think about how to parameterize this in Grasshopper, is just draw it and write down every step you're doing in Rhino. Don't do this for a lot. I mean, just do it maybe for this, and then say, okay, you know, this is what I need to do next. How many ways can I do the same command, right? And then the key is how do you start stitching this together where you start changing one or two parameters and producing the outcome. All right, so we have both possibilities here. This is in the wrong position, right? So we'd have to move it. So let's go with this one. So now we did an offset. If we just look at offset, there's offset surface, but we don't want offset surface. We want offset like a line, right? And in this case, we need the edges of this. So if we do a brep explode again, or deconstruct brep, they always change the name of these things. We get all the edges. So if we take a, so what I'm doing now is, I'm going really fast, guys. I know this because I'm trying to get a lot done. And again, I'm recording this so you can take a look at it. What I'm doing is taking the edges. So if I turn this off, and I turn this off, all am I doing is extracting the curve edges. And then I can offset them. Okay. Now let's look at some options for offsetting. The corners, so if I look at this, I'm like, okay, that's not right? It's not, my corners are all messed up. So here, the last one, C, we can either do them as a sharp, a chamfer, a smooth, a round, okay? So sharp is 1. So I need to set this to 1. Or I just come here and go to sharp. It's still not doing it. Chamfer's not doing it. So we have an issue of it, these curves being not connected, right? So we can do a join curves. And like we would do in Rhino, do a join command, it would join the curves. Now we can go back and take this to sharp, and we have our sharp corner. Next we have our extrude. We want to go in the Z direction again, right? And we want a slab thickness here, right? So let's just leave it what it is. And then we can do a cap. And we have our slab. Now again, if I change any of this, it's going to adjust. Okay. What you guys are going to do with these, everybody's going to build their own. What we're going to do next week is start applying facades to these things. Okay, it's really basic modules, and start talking about detailing, modularity. We'll look at facades, like what does that mean? Okay. What I want you guys to do is take this. I'm going to give it to you, but you need to make it. You need to do a Z now. So we want to have a multi-story. So you need to add one parameter, which is going to be adding a story. Okay? Does this make sense?